Hi, this is Dr. John Bergdorf. In a previous video, we defined what is meant by a logarithmic function, and in particular, we looked at how to graph the logarithmic function with base a, which we're going to start this video with a review of that. But in this video, we also want to look at graphs of logarithmic functions that are a little bit more complicated. But like I said, let's start by looking one more time at the basic graph of the logarithmic function with base a, which would be defined by an equation of this form. And from the previous video, we can remember, for example, that a graph of this, a function of this form, its graph would go through some key points. The domain of the function is 0 to infinity. The range is negative infinity to infinity. The graph will be continuous and 1 to 1. There will be a vertical asymptote, exactly the y-axis, and if the a, the base, is greater than 1, then the function is increasing. If it's between 0 and 1, then it's decreasing. So just quickly here, on the right part of this slide, there's a graph of the function defined by f of x equal log base 4 of x. Let's take a look at these key points, for example. The point 1, 0 is clearly on the graph. We can also see that the point 4, 1 is on the graph. That would be this one and this one. And 1/4, negative 1, that would be right about here. And that appears to be on the graph as well. The domain is 0 to infinity. The range is negative infinity to infinity. Continuous 1 to 1, the y-axis is a vertical asymptote, and because the value of a is greater than 1, the function is increasing. Well, if we take that basic view of the basic logarithmic function with base a, we can then apply what we already know about transformations in graphs to look at slightly more complicated functions. And we're not going to get too carried away here, but I've got a couple that I want us to look at. So, f of x equal log base 4 of x plus 3. I can tell that this graph will resemble the graph of logarithm base 4 of x that we looked at before. Looking inside the function, I see that we have an x plus 3. If something is added or subtracted inside the function, inside the parentheses, that will cause the graph to shift left or right, much like we've seen in many cases before. If it's x plus 3, that means that the graph will shift 3 units to the left. So this graph will resemble the graph that on the previous page, but shifted 3 units to the left. Now, how are we going to actually make that happen? Well, here's what I would recommend. Let's look first of all at that sort of underlying basic function that is going to be most similar to this, logarithm base 4 of x. Think specifically about the key points that are going to be on it. So looking back a slide, we know that the point 1 over a comma negative 1 will be one of them. In this case, our a is 1/4, so this will include the point 1/4, negative 1. Looking again just at the basic, the logarithmic function of base 4, all logarithmic functions, all simple logarithmic functions of that form go through the point 1, 0, and then the last point that we specifically mentioned is the point a1. A is your base, so that would be the point 4, 1. So I think about those specific points, but then on top of that, I bring in what I remember about the transformations. So like many other graphs that we've seen so far, think about where the origin would move relative to whatever transformation is being described. So if I ordinarily have my origin at the origin, and I shifted 3 units to the left, that would put it right here. Now the important thing to know is that just like the basic logarithmic function, there's going to be a vertical asymptote, and the asymptote structure shifts along with the remainder of the graph. So in general, the logarithmic function of base 4 will have the y-axis as a vertical asymptote, but that will slide with the transformation 3 units to the left and put the vertical asymptote right here. We'll write down the equation of that in a minute. Then we measure all the points, all my key points from the new origin. So here's the way we really want to think about this. This is saying, this first point is saying that relative to the origin, really, there is a point that's 1/4 unit to the right and 1 unit down. Well, measuring from sort of the new origin, we would now, again, from this origin right here, move 1/4 unit to the right and 1 down. You should begin to see the shape recreated, so to speak. Notice that this graph is not going to go through the origin, but another point is the point 1 unit to the right and no units up or down. So relative to the new origin, that would go right here. And then finally 4, 1 would mean relative to the origin, the new origin, 4 units to the right and 1 unit up. And you can see then the same logarithmic shape, just shifted to the left. And that's how you do it. In this one, we're going to have both a vertical and a horizontal shift. So we're going to observe, first of all, that this graph will resemble the graph of f of x equal log base 1/3 of x, but with a shift. We'll talk about the shift in a minute. So we may first want to remember what this graph would look like. And my key points, my first point goes with, and we'll go back to look at this original slide. The first point is 1/a, comma, -1. My a here is 1/3. 1/1/3 would be 3. So this will include 3, -1. Always, all of the logarithmic functions, the basic logarithmic functions, the logarithm with base a, all of those go through the point 1, 0. And then finally, they also go through the point a1. So 1/3, 1. Now, we also are going to pay attention to our transformation. The x minus 2, the -2 inside the parentheses, inside the function, that is going to create a shift of 2 units to the right. And the -4 at the end, outside the function, is going to shift the graph 4 units down. So like in many, many graphs we've done, and like the one we just did, imagine the origin and where the origin shifts. My origin's ordinarily at the origin, but if I shift it 2 units to the right and 4 units down, that puts me right here. And the asymptote structure will go with it. So the asymptote is ordinarily a vertical asymptote at the y-axis. That will also shift 2 units to the right. Now, a vertical line shifting up and down is still the same vertical line. So my vertical asymptote will go like this. And I will keep in mind my new origin, but remember the new origin itself is not a point on the graph. Everything is measured from that point. So my first point says that there should be a point from the new origin 3 units to the right and 1 unit down. So let's see where that would be. From the new origin, 3 to the right and 1 down. The second point says there should be a point 1 unit to the right and no units up or down. That's the 1, 0. And then finally 1/3, 1 from the new origin, 1/3 unit to the right and 1 up as best you can. And remember that if my base, going back a little bit, if my base is between 0 and 1, the function will be decreasing. And I think we can see that the graph will approach the vertical asymptote, shift through these points, and proceed on like that. All right, I hope that helps. We could actually have made this fancier, but for logarithmic functions, I think we'll be happy with just this.